Hello everyone. Let's begin our work. Before starting, I want to check the CPU uses of my laptop. Fine. Today's problem is problem number 1674. Minimum moves to make array complementary. Okay, makes sense. Let's go with the problem statement. I hope it is recording well. Yeah. So right now it's exactly 139. Let's consider it as an 140, and I will invest 1 hour for this problem. And for the first 45 minutes, if I fail to answer this question or complete this question, then we will take help. No, let's make to first 40. If I am clueless in first 30 minutes, then we will straight jump to the solution and then uh, learn from it and then do it. And if I have some solution but I have some ambiguity, then I will stretch it a bit further. So let's go with the problem statement. You are given an integer array nums of even length and okay, an integer limit. Fine. In one move, you can replace any integer from nums with another integer between 1 to limit. Okay, I can replace any integer of an array, that is we have nums array with the value 1 to limit. The array nums is complementary if all indices I, which is 0 based indexed array, uh, nums of I plus nums n minus 1 plus I equals the same number. Okay, makes sense. For example, array 1, 2, 3, 4. So basically, makes sense. So how they are considering the move? In one move, what we can do? In one move, we can replace a particular element with a given range of numbers, that is 1 to limit. 1 to limit is inclusive, right? Yeah, makes sense. Question is a bit straightforward, and the solution, let's think. So basically we need to find out one particular number that will lead us to the complementary leaders to the complementary array, right? As the criteria or condition says that if I add two if I add let's not go with very detail. If I add two number of a array, I will get a number, addition number, added number, that sum uh, that sum we need to find out first, because that's the point. Based on that number only, we need to uh, organize or replace the numbers within the nums array. Fine, let's think of that number first. Okay, first of all, limit plays a very vital role, because we are not like we can replace any number with any number to achieve a summation target number. Okay, we cannot do that. So for example, here we have 1 and 3, right? The addition of 1 and 3 is 4. Okay, nice. And then we have 2 and 4, so addition is 6. So the question is which one to consider. It will be optimal to consider the number which is all which has already highest number of summations. Yeah, makes sense. Let's take a bit bigger. Okay, we don't have that kind of uh, answer example over here. Fine. For this problem statement, what it does that it replace it replaces the element 4 with 2, so it will make it, the summation will be 4. Fine. Mm. So target should be figure out what should be the, again it seems okay. Let's first understand what could be. We have the target, okay, 1 to limit, okay. Okay, again, this again feels like a binary search question. Why I'm telling this? See, binary search on answer again, BS on NS. Okay, why I feel like this? Because binary search on answer works upon a function or a method which act as a predicate. Okay, so let's define that function. So let's say if I have a array, sorry, if I have a function is possible, again, which will have nums and and a target, okay. So what it is doing, okay, I will also pass the limit to figure out to use that value, okay. Hmm. Okay, I don't think limit is needed. Wait, let's remove limit. So what does this method do is, mm, takes the array and takes the target sum, okay, uh, and figure out whether it is possible to do or not. Wait, if it is possible to do, if it is possible to do, how exactly how exactly it will check, how exactly it will check whether it is possible or not. Let's say I have this target has a range between 1 to 4. Hmm. No, not 4. This target should have the range between. Hmm. Okay, okay, okay. So this is even size array, right? So we can have one thing to find out the range. Range will never exceed these combinations, right? Combinations like this: 0th index and the last index, second index and second last index, and third index and third last index, right? So I can simply have I have an array or whatever. I can find out this max of this will be right, and left will be 1, and again target is nothing but the middle. Fine. And here we are checking that here we are checking that for that particular target, am I able to am I able to um, am I able to do the solution or not? Am I able to make it no one there one more thing. So target it's not that easy question. Okay, let's think very naive. Okay, see, what is my goal? My goal is to find out the difference between all the. So basically, I have two numbers here. Since it has four sides, so I have the two numbers, two summations, and I can check what is the difference among them. There can be a lots of number, and we can check what is the difference. And again, we can also choose. Okay, there is a really nice. So it should not be like from 1 to this max of this value. Rather than it will be better for the given array, it creates an array of summation, like array of this. Okay, and sort it. After sorting it, it will give us. Okay, we are looking for the minimum number of moves. Should I think of greedy or not? I'm thinking. What greedy solution says that uh, just create the array of difference. Sorry, just create the array of summation, and whichever number has the highest frequency, go with it. Consider that as an target and try to figure out whether yeah, nice thinking. Try to figure out whether it is possible to make the array to achieve that target. If it is possible, then well, it's a most it sounds like most minimum, or it sounds like the minimum number of moves required, because we have eliminated most of the uh, numbers. Okay, okay, let's wait. Let's think about it. Let's a bit bigger example. 1 2 4 3 7 2 8. Okay, 1 2 3 4 5 6 7. So we have to have 9. Okay, then no, wait. Yeah, it's better. So what are the summations? 10, then again 10, then it's 6, and then it's again 10. Wow, such a nice example. So here what I will consider, that I will consider 10, since it is I will consider 10 as my target, because it has highest number of frequency, so which lead me to make changes for the minimum number of element. Okay, that's crazy question. I have limit which can, अगर ऐसा होता ना कि कोई एक को ही मैनिपुलेट करने से हो जाता, लाइक ये 6 कैसे जनरेट हो रहा है, 6 इज कमिंग फ्रॉम दिस टू, दिस नंबर एंड दिस टू. अभी मान लो लिमिट अगर 3 होता, तो 3 होता तो क्या कर लेते, 3 and 3, ये तो फेल हो जाएगा, राइट? Okay, nice. So maximum target can not be this. Maximum will be simply as simple as that. Maximum will be limit plus, or sorry, into 2. Where is into 2? Because even though we change two number, two complementary indices, uh, it lead me the number at max. It will be a limit into limit, limit plus limit, maximum value of limit plus maximum value of limit, and the minimum value of limit is 1, and so okay, so it will not be 1, it will be 2, because left is just minimum value of limit plus minimum value of limit into 2, and right is maximum value of limit into 2. This is my range from 2 to 8, and again we are doing the summation of two number. Does the summation of two number can give me odd number? Let's think. 1 comma 3 gives 4, and 1 comma 2 gives me odd. Okay, so let's even plus even, even, odd plus odd. 3 plus 5 is 8. Even, even plus odd. 3 plus 4 is 7. Odd. Okay. So as we were going with this basic steps, नहीं यार, देखो टारगेट ये भी नहीं हो सकता है, लेफ्ट ये भी नहीं हो सकता है. लेट्स से लिमिट, ओके, ऐसा कोई कंडीशन है क्या, लिमिट का क्या वैल्यू होगा? limit will be always greater than all the values of, see, that's the catch, right? Limit will be always greater than or equal to any number of elements in num. That solves a big problem. Okay, since limit is bigger than greater than any number of array, any element in an array, that resolves a lot of problem for this case. So this thinking is actually correct. Just because this condition is in our constraint. Uh, I don't know how would I able to solve it if limit has can have any number like less than any of this number. That could be a bit tricky, but this is a bit good, better. Mm, fine. So uh, I cannot say that limit is less than 9. Okay, in this case, it could be 9 or greater than 9. Okay, or greater than equal to 9, whatever. Okay, limit is greater than equal to 9. So yeah, it's good. It's good that limit is greater than equal to 9, and limit is greater than equal to 9. Okay, then I don't even need to consider the values from 2 to limit. I just need to consider the value from limit to uh, limit to 2x twice of limit. What value does they consider? They consider the limit. What value they considered? They consider the limit again. What value they considered? They considered value greater than limit. So it will not be limit, it will be just simply limit. Okay, let's implement is possible first and then think whether it makes a feasible solution or not. There is another question is like to implement this, it, it's also a tricky part because okay, because wait, should I go with the hint? Wait, last attempt. Wait. Let's take the hint for the problem. Given a target some x, pair this would be either need 0, 1 or 2 modification. Yeah, it's pretty basic, right? So second hint says that can you find the optimal target sum x that we are also looking for such that the sum of the modifications is minimized. Okay, okay, sum of the modifications is minimized. Sum of the modifications, like what value, how much value does it matter? What, it's the same thing I am doing, right? The count should be minimized, right? I'm doing the same thing actually. Count should be plus plus, and now think how many times it will occur. So for 6 its count is 0, right? And but I'm not able to figure out how will I move. Create a difference array to efficiently sum all the modifications. Difference array, and I was thinking to create an summation array. Hmm. Understood, understood. So what the hint is saying that rather than creating summation array and then check, just create the difference array and do the summation of all the modification required. Okay, wait. Let's say I have 1 2 3 4 4 1 2 4 3. uh, I'm sorry. 1 2 4 3. Difference array is 2 and then 2. Sorry, difference array is 1 and then 2. So how many variations it has? Two variations. Uh-huh. This could be the answer. Like, just create the difference array and check how many distinct value it has, and the distinct value minus one will be the minimum number of moves required. Mm, yeah, distinct value is two, and one is required. In this case, one comma two comma two comma one. So difference is 0, difference is 0. So basically difference is 0 0. It doesn't make any sense. Difference is 0 and then difference is 0. Hmm. Let's move to the discussion. Okay, fine. This question was in a contest. Medium, medium my ass. Gonna work at McDonald's. Is this a dark side of lead code? So sweep line it is. First, I was happy to get a medium question in today's challenge, but got an instant reality check moment. And actually, this question is not making sense. Like I'm going through the greedy solution. I'm trying binary search. I'm trying basic like what could be the see the whatever the it is saying it is not making sense to me. Wait, what it is saying, give a target sum x that I was thinking of. For each pair of this and this would be either 0, 1 or 2 modification. Okay, I'm not happy with the 2 modification. So what they are saying, we have nums of I and then we have nums of n minus 1 minus I. So among these two number to achieve to get the summation as like let's say it has 1 a plus b is equals to c is our target. Okay, c is fixed, c is fixed. What could be the scenario? Either we don't need to change any, we don't need to modify uh, the value of a, or we don't need to modify any value like a and b actually making c. And there can be a scenario where I need to modify either a or either b, or there can be a scenario where I need to modify a as well as b. So there are three scenarios. I completely understand this, but three scenarios. Three scenarios means either it is going towards dynamic programming or what. Three at any point. At any point, I have three scenarios. Either make no changes, make either of them a change, and then or either make both of them. Again, there is four scenario. Either I change none of A or B, either I change A or I change B, but both the scenario, either changing A or either changing B, will count as one one move only, right? Or I need to change A as well as B, so two. Okay. Okay, this is so crazy. I got it. Let's say I have left. and I have right, my target is this, and I want to achieve this. So based on this thing I can do that, right? Based on what? Wait. My target is this, and okay. I don't know the use case of limit. I don't understand this. Why? I don't think. Okay. In entire assumption is wrong. My entire assumption is wrong. Wait. I I need to consider a value among 1 to limit. This is the hardest part actually. I need to consider the value from 1 to limit. And how will I understand whether how to control it, bro? If difference if difference is within limit, then it is good to go, or what? If yeah, it's like it may be like if it is okay, as there is three scenario, either one changes, two changes, or three changes, right? Zero changes is pretty much easy. If a plus b is c, then there is zero changes. Makes sense. If okay, wait. If a plus b is equals to c, zero moves. If else if actually if a plus b is less than or equal to limit, then it will be one move required. If a plus b is greater than limit, two move required. Let's justify this first. Why? Let's say c is 5, a is 1, b b is 3, and c is c is 5, and limit L is okay. Limit एक एरे के लिए एक टारगेट एक्स पकड़ो और उसके लिए चेक करो कि इसको इसमें चेंजेस करना है कि नहीं. वो कैसे चेक करेंगे? इसको और इसको चेक कर लो. अगर टारगेट सी से बराबर आ गया, लिमिट ही रखो यार. रुको. अगर वो टारगेट बराबर है तो ज़ीरो मूव, या फिर अगर उससे थोड़ा सा कम है, ठीक है, मैं 5 अचीव करना चाहता हूँ. और अभी मेरे पास 4 है, तो कोई एक नंबर को बढ़ा दो, हो गया, राइट? एंड अगेन अगर मैं अचीव करना चाहता हूँ 5, बट मेरा नंबर ही 10 और 6 है, या फिर वॉट एवर, ज़ीरो ही क्यों ना है. ओह शिट, दिस इज़ क्रेजी स्टफ ब्रो. इफ़ इट इज़ ज़ीरो, देन इस सिनेरियो में भी मैं अगर इसको सिर्फ 5 कर दूँ, तब भी वो उधर चला जाएगा यार. दिस इज़ क्रेजी. हाँ ओके. अगर ए और बी दोनों ही सी से बड़ा हो जा रहा है, तो समेशन भी सी से बड़ा होगा. इट्स नॉट लाइक ए और सी, ए प्लस बी सी से छोटा है तो एक मूव होगा, और या फिर ए सी से छोटा है और बी भी सी से छोटा है. क्रेजी भाई, क्रेजी. दिस I don't think I will be able to do it right now. I have only 10 minutes remaining. Difference array intuition. Wait. Difference array intuition. What I will do with the difference array, bro? Let's say I have the difference array and then what? Difference array and then prefix. What does it mean, bro? Difference is 1, then 1, then 1. A single element can be changed to any desired value within one value, one move or no move. A new value is capped by the limit this. Let's try with this example. अगर ऐसा है तो ये हो गया 1 और 1 smallest. If we check any arbitrary pair, we know that range will be lie from 2 to the 2 into limit. That's correct, yaar. I know that. Chalo. Bro, this is crazy. I'm not able to understand anything, and I'm thinking something out of the box. Crazy. I'm not able to catch up this problem. Wait. From here, I got distracted. I understood till here. Figure out this pattern helps us to build a simple adjustment marker array in just a few iteration, which which later allow us to rebuild the moves exact moves array using a line sweep. What is this adjustment marker array line sweep? I don't know any of this. Here is how it works for a single pair. Create the marker costs Create the marker costs only 5 operations, while rebuild it takes crazy. What is what he is doing? I don't understand any of these things. what 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 is this, bro? This is crazy. The delta array. Delta array of size whatever what of size 2x of the limit, and then plus 2. He could have simply write limit into 2 plus 2, and then whatever he's doing. Honestly, I didn't understood any of these. Line sweep. Line sweep, what it is, bro? For the first time I hear this term, line sweep. It is meant to be happen this that. Line sweep is also used to solve this maximum frequency of an element after performing operations 1. What it is, bro? What kind of solution is this? Crazy, bro. I don't understand any of these things. what is this? This is pure difficult. Here is a simple brute force way to solve this. You can easily optimize by prefix some line sweep on binary search. This is the first time I heard this term. Fine. Check every possible target sum that we could aim for each pair this and this. So for every target solution you can go from this to this. For this target, check the cost of every pair front to back. Okay, A, and then cost of like y, calculating the same thing two times, A and then again, okay, max of this and mean of this. Okay, A is a minimum and B is max. Rule 1, the pair already adds up to our target perfect. Cost is 0. Yeah, that's what I was thinking here, right? Rule 2, target is reachable by changing just one number. Cost is one move. How do we know? Yeah, that's what I was thinking here. The lowest we can go by changing B to 1 is A plus 1, and highest we can go by changing A to limit. Oh, okay, 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 okay. Either we can change B to 1 as A is A plus 1, or else we can simply high lowest. Okay, okay, I want to reach a number, and to reach the lowest number, what I will do, I will make the highest to 1, or if I want to highest number पे जाना है, then we will change A to limit A plus, like minimum value plus 1. T is greater than equal to A plus 1, or T is less than equal to, okay, that's what conditioning I was thinking here, but I thought it's wrong. This is the perfect solution. This is the perfect solution. Yeah, I got it. Time complexity, TLE. Why TLE? I don't get it. Like there is no. Okay, limit is. This is the solution I would have come up with.
Hello and good morning to everyone. To do, we have to take the minimum of
Hmm, let's read it again. Wait, intuition for array to become a complementary, it must be like this. We try to understand how many moves need to make a pair equal to a target sum s. Suppose we have a pair a and b where a is less than equal to b, we can have zero moves where a and b already make the target sum s, and we need one move where we will keep a and change the b, or we will keep a and change the b, or we will keep b fixed and change the a, right? Combining both the range, this is the solution, right? So so target, so every target sum inside the interval can be achieved by, okay, any target sum outside the range requires changing both number. Yes, makes sense. And instead of instead of checking the every target sum for every pair, we use the difference array. Okay, like अभी मैं सारे pairs के लिए चेक कर रहा है. assume every target sum needs two moves. Okay, पहले सबको टू 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 कंसिडर करें. reduce moves on the one interval reduce moves more, reduce one more move at the exact sum. Okay, this is nice. Finally, the prefix sum gives the target. I don't understood this. What does it mean? I have a diff, and where I'm okay. This is crazy. I have a vector. I don't understand this. Why having two extra size? I don't get it actually. Let's say A is this and B is this, and like that the same thing that I'm doing here, A and B. If int left is A plus 1 and B, left and this left and right is a range for reducing one. Okay, assume two moves for all the sums. Okay, difference of difference of 2 plus 2. I don't get it. Why? Like I don't get it. So this is the game. अभी क्या है यहाँ पे? रेंज फिक्स कर लिया गया है कि 2 से लेके लिमिट प्लस लिमिट तक रेंज होगा, राइट? स्मॉलेस्ट सम क्या हो सकता है? 2 हो सकता है और लार्जेस्ट सम हो सकता है 10। अभी क्या है कि हर एक सम का वैल्यू के ऊपर आइट्रेट करेंगे फॉर ईच इंडेक्स, या फिर ईच इंडेक्स के लिए हम कंसिडर कर लेंगे कि सब के लिए दो दो मूव लग रहा है। 1 1 2 0 0 0 2 2। I don't understood this, bro. फाइन, आज का क्वेश्चन मैं खुद से नहीं कर पाया, बहुत ब्रेन एनर्जी चला गया। आई एम सो सैड टुडे, बट इट्स ओके, कोई बात नहीं। समझ में आया, क्वेश्चन बहुत ट्रिकी है, मतलब खुद से कम अप तो नहीं कर पाएंगे लोग। हाँ बट मतलब बहुत अच्छा थॉट प्रोसेस, ठीक है, ऐसे ही ट्राई हार्ड करने से ही होगा। चलो।